Hey everyone, um, my name is Dmitry, and today I'd like to walk you through what's new in images and the web performance. So we'll talk about how to put your images on the web pages so they will load fast, but at the same time will be a good quality. It's also my first stream, so if you notice that anything wrong with my audio or video, just let me know in the chat, and I'll appreciate that. So let's get going. So also the level that I expect you to know is just basic HTML, and just be familiar with the img tag that you would usually use to put images on the website. And just so we go through the story, we can't just jump into the images first, but we'll look into the web performance and what it is and why we need it. And then after that, we'll jump into images and look into some of the problems that, or opportunities, better say, that we can take to make them load faster. So that would be next generation formats, lazy loading, fetch priorities, responsive images, and DPI with height, and how it affects cumulative layout shift. So let's get into it, and we'll start with the web performance. So what is web performance? Web performance is basically making websites fast and responsive. The interesting thing is about it is that it's making websites faster is pretty clear. Though the one interesting thing to think about is that sometimes you can also give user a perception that websites load faster. So the things like spinners and other things that make users feel that websites is loading faster than it is, which is also, I believe, part of the web performance. But why would we even bother to make websites faster? And the answer, of course, is because making websites faster, driving up our business metrics, like conversion rate or revenue per visitor, or the bounce rate would go down. And on this slide, there is a very good website, WPO Stats, which is just basically list of case studies of how web performance affecting business metrics. So I recommend going through it. There is another one which is on a web dev. You can search by tags, and there will be a bunch of case studies there as well. And as you can see, so web performance directly affecting the business metrics. So, and that's how you usually would go about it if you're working in the company and you think that your website is not fast enough. Then the main thing is to get everyone on board, and I guess this is something how you can get the product owners or product managers jump on board as well. So, but it's not just about business metrics, right? I think, and this is what I truly believe web performance also give you, is a great accessibility. So I'm living in Australia, and I just went camping last week, and there was no reception there, and I had to climb 3 kilometers on the hill to get some to get some reception. Do you know why did I do that? Well, because I bought everything to do a mulled wine, but I didn't download the recipe. So I wanted to look up the recipe, and I had to go through pretty much first 10 links from the search because the website just wouldn't load on that slow 3G. So, and this is what really then the part of this accessibility means, that there are those distant places where the connection is not good, and we don't always have those fat broadbands. The same as with different devices, there are like cheap devices that might not run all the JavaScript in this world and would struggle with that. So that's another angle to look at web performance. And of course, it's SEO as well. We'll talk after this about the performance metrics, and Google just measures them and also using them as a ranking factor. So if you have two websites that look the same, have the same content, but one is slower and the other is faster, then the one that faster will rank higher. So then what is web performance? How can we measure it, right? That's probably where we start. And probably in the last years, Google came up with the metrics to use to measure web performance, and call them core web vitals. And I think they are reflecting web performance pretty well. So on the top, you can see that there are three metrics. One of them is measuring loading, another is interactivity, and the third one is the visual stability. So LCP is largest contentful paint, feed is first input delay, and there is a cumulative layout shift. So pretty much if you want to make your website fast, you would need to be in the green of all these three metrics. Interestingly enough, the first input delay is slowly probably getting replaced by the interaction to next paint, and that's because first input delay is only measuring the first interaction, but interaction to next paint is actually including total of all interactions. So then largest contentful paint is about how quick we can see the biggest chunk of the web page. Cumulative layout shift is about those annoying websites when you just load it and you start reading and then something comes up on top and the text just slides down. So that shouldn't happen, and that cumulative layout shift is what measuring those layout jumps, and we'll talk about how we can avoid them, and why and how images might affect that as well. So yeah, as I said, interaction to next paint is the new metric. It's not. I don't think it's yet part of the core web vitals, but it will. The idea would be that it will slowly replace the first input delay. So how do we measure those core web vitals? The way that Google measures them, and you can also look at them, is as a field metrics. Field metrics means that when user gets onto your website, it's just getting the measurements, and then they're getting sent to the central database. And you can get the information from the central database using those field tools, which is Chrome User Experience Report or Page Speed Insight, or it's also integrated into Google Search Console. However, having just those metrics in the field won't allow us to see how changes are impacting. If we make a change to the website, then we want to see how it's impacting these metrics. And for that, we want to measure them in a lab. Probably the most popular tool here is a lighthouse. Yeah, so that's probably what everyone is using mostly. Yes, Lighthouse is integrated into Chrome, and you can just open the web developer tools and go into the Lighthouse tab and then measure all those metrics that I was talking before in it. And then believe it or not, this is my face. I can just move it here. Believe it or not, most of the time when you're dealing with the web performance, it's either media or JavaScript, and I guess the tricky thing is that fixing one of those is not really solving the bigger picture. So you can fix the JavaScript, but then if you have pretty terrible, huge images, it will still keep affecting those other metrics. So I think what is good is to kind of trying to figure those problems in complex, and then yeah, try to address both media and the JavaScript. So another hint that I probably can give about, and this is just from my experience of looking into the web performance, is because it's very hard to measure anything on the live website, because things are changing. There are new marketing campaigns, advertisements, new products and things. So it's very hard to measure the impact. But with the web performance, it's actually quite possible. What we want to do is to just pick the lower range of, let's say, devices or network bandwidth, and measure the business metrics on those clients. So let's say we can take the conversion rate on 20% of the slowest on 20% of the users with the slowest connections, and then by optimizing the website, we should see actually big changes in those 20%, and then you can see if you are going in the right direction or not. So let's talk about images and how images and image optimization affects those core web vitals that we were talking before. And we'll probably start with next generation formats and what it is. So as you might know, we usually would have the source image would be a JPEG image or PNG image, and then we would use one of those in the IMG tag as a source, and then on the page loads, then we will see the image. However, about 10 years ago, the browser started supporting another image format called WebP, and then just recently, well, not recently, but probably almost a couple years ago, there was another image format which called AVIF. So if we compare, WebP is usually twice smaller than JPEG with the same like a visual perception, and AVIF could be probably around 30%, on average 30% smaller than WebP. So just using the different file format, you can just save like 70 or more % on the bandwidth that you transfer to the user, which then will make it load will make it show the image much faster and much quicker. I guess the other thing to pay attention is that JPEG is a lossy format, meaning that once we compress the source image into the JPEG, we will never get the original because it's actually changing the image. On the contrary, the PNG is lossless, so when we are using PNG on the original image, it's just the same original image. Yeah, and WebP and AVIF, the next generation formats, they are supporting both lossy and lossless compression. So another format that is in the makings right now is a JPEG XL. It was actually included in Chrome as an experiment, and then there was a huge saga about Chrome developers that actually took it off there. The reasons are, well, they kind of not too clear. However, I think that the main reason is that if you look at the Chrome code base, you'll see that it's a bunch of libraries and a lot of code, like a third-party code that is just gets compiled as part of the Chrome. So adding any new dependency will can affect like a security blast radius and like other things. So, and I think that's what was called the main reason. And if you think about AVIF is used for video and for images, which is good and bad, because JPEG XL is much better and feature rich for the still images. But yeah, it's as of now, it doesn't look like it's going forward. However, there is a link at the bottom of this slide that you can check out. The developers of JPEG XL are trying to create a new library called JPEG Li, which will be ABI compatible with the libJPEG, but then it will be like a JPEG images that will have a lot of features from JPEG XL and should make them much smaller. That's something that the space to watch, I guess. So, how popular are next generation formats? This is from 2022 Web Almanac, and as you might see, WebP is pretty much 10 years old, but still it's only 8.9% of the images on the internet, and there is no AVIF here at all. However, on the right, you can see that even though there is no like a big portion of AVIF there, but comparing to the last year, AVIF adoption jumped by 400%, which is pretty cool. So it's slowly moving to the right direction. So, and that's when we're talking about next generation formats, that's what you want to see and that's what it can give you. So here's an example of the mix of images that are using next generation formats and also using the HTTP3 to deliver those images to the client, and versus the normal, like not optimized images just delivered through the HTTP2 protocol. So, and you can see here that those optimized images are much smaller, but then also like the time to download them is like 49, so it's all below 100 seconds. The sizes are 5 kilobytes, whereas like all not optimized images are quite large and then also takes much longer to load. So that's probably one of the things why you want to consider using next generation formats and the modern network protocols, which is the HTTP3. The HTTP3, it's already like a couple of years as of like it's been available. However, I found that even though like many CDNs are do support them and like cloud providers, but sometimes you need to actually go in the console and enable it, saying like enable HTTP3 or quick if when the negotiation comes from the browser. So yeah, that's maybe why we don't see that high adoption of HTTP3, even though it's supported by pretty much all the major players on the market. So, and that's what we typically need to support the HTML code that we need to support the next generation format. So the idea would be you have your source JPEG image, and then you need to also convert it into two formats, which is AVIF and WebP, and then you can use picture tag in order to show the image on the web browser that supports that format. Saying that all the major browsers, like including Safari, they already support AVIF. But yeah, if you look at the Internet Explorer, Edge, or what's not, then yeah, they might only support WebP, and some probably older ones might only support JPEG. So you would still need fallbacks to those old formats. And then that's where we kind of go into this image CDN space. So what image the main purpose of image CDN is to provide those image formats for you, and also like doing some image transformations there as well. The way it usually works is like the browser sends a request saying give me that image, and then it will go to the CDN and check if it's in CDN, then it will just serve it from there. If not, then it will go to the API, and API will get your source image and then optimize it and transform it, and then send it back. It will be cached on the CDN, and then it will be served to the browser as well. So that PixBoost image CDN that we have, it's actually open source. So there is a link down the bottom here. It's open source microservice it's just a web service that you can install in your infrastructure and start using it. Why it's better? Because it's highly opinionated, and we are trying not to include too many like options and choices, rather than being quite opinionated, but then hide all the smartness in the code. So then we saw just before what here what the code looks like when we need to add support of next generation formats into our markup. So if we use image CDN, then we can just use normal IMG tag, and the image CDN will figure out what format to serve when it's doing the request. And that's pretty much about next generation formats, and we are moving on to the lazy loading. So the idea behind lazy loading is like we have a web page, and some of the images that are not on the top of the web page, the user actually won't see them. So what we can do is not to load them, but when user starts scrolling to those images or like opening some elements and things, once the image is actually visible in the viewport, then we can show them. Back in the days, the very first implementation of lazy loading was using like on scroll event. Every time the user will scroll, the bunch of JavaScript will kick in, start looking at the bounding rects and other things, and trying to figure out if the image is visible or not, and if it's visible, then it will load it using JavaScript as well. That was pretty horrendous. And then I think maybe 3 or 4 years ago, there was an intersection observer spec that would just allow us to like add a listener and say, hey, if those things intersect, which is the viewport and the image, then we can load it. And that was the probably the best way to deal with it thus far. However, probably or maybe a bit more than that, there was a new attribute in the HTML standard for images and iframes that would say where you can pass the loading attribute and you can pass the value lazy, that will say that we want to lazy load it. So bang, we don't need any JavaScript whatsoever now. And that's the way to do it. There are so many frameworks and like CMS and others that are using like either that on scroll approach or intersection observer. So you could see like very popular libraries like Lazy Sizes or Lozart or others. The main goal of those libraries is to actually using JavaScript lazy load the images. So if you see those, this probably would be a red flag and you want to have a look what's going on underneath it and update your images to just use the loading attribute in your markup. Yeah, so if we look at can I use, it's already supported by pretty much Chrome, Firefox and Safari. Firefox, I think, still just only supporting it for images, not for iframes. Same for Safari here. It was only supporting for images, and but now we pretty much can, like for images, we can use that loading attribute, and it will just work across pretty much all the browsers. So with the lazy loading, before we go into the demo, see how it's working and what the good practices are, there is another new thing that happened just recently is the fetch priority. So you can just there is a new attribute fetch priority that you can specify on the image, and if you put it in value high, I think it's like only it supports two values, like a normal and high, and then normal would be the default value, and then high would be the other one that you can use. When it's high, it will tell the browsers that I need to run and load this thing very first. This is something that before we had to use like a different preload techniques. So instead of doing that, excuse me, instead of doing that, we can just use that attribute now. So yeah, and there is a link here pretty much that explains what the fetch priority is, but the main goals of the fetch priority is to boost the priority of LCP image. LCP is largest contentful paint, the one of those web vital metrics that we were talking about before. Wait, let me just move myself out of here. And then so if we use fetch priority high, then the largest contentful paint will happen sooner. Okay, I'll put myself back. And then so it's better semantic than those preloads that we used before, and it's also will decrease the priority of body scripts. So instead of loading those, it will load the images. So yeah, the main use case is probably those LCP, like a hero bonus and images. So if we combine the fetch priority and the lazy loading and have a look on the website, so here's what's supporting. So yeah, the support is not great. It's pretty much just Chromium-based browsers. However, if you go through the bug reports that the feature requests that filed across other browsers as well, like Firefox and Safari, there is not much objections to that, so I would expect that we will get them across all the browsers soon. However, even if it's not working, then it would just load with normal priority on those browsers, so it won't break anything. So if we combine lazy loading and fetch priority, and then we have this website, for example, that's loading on the mobile phone, then what we'd like to do is to have loading eager, which is default. So if you don't specify loading lazy, if you don't specify loading attribute, that it will be eager by default. So for this top image, we would like to have a fetch priority high. As you can see, it takes pretty much half of the screen. So this will be our largest contentful pane. That's why it's important to load it as soon as possible. It also will probably give all the context, should give all the context in the world for the user about what this website is about. So then those listing pages are a bit interesting. So I often see the implementation where like all the images on listing pages will load lazily. However, if you think about it, usually you would still see first or second row of those product images. So it would make sense to actually load first row, second row, whatever is visible, just with the eager value, and then the rest might actually go as a lazy loading. I believe that's probably would be the best way around this. So next is responsive images, and this is where it's getting very complicated and tricky. So yeah, the idea is that we have one image and we want to display on all the different displays and screens. And there are two things about it. One is the sizes. So every display have different size, which is quite understandable. However, there is another thing, which is DPI, that adds like a lot of complexity into this. So let's have a look on the DPI first and what it is and why it's tricky. So Apple on iPhone 4 first time came up with a retina display, and you can see on those images comparing the iPhone 3 and iPhone 4. Right. So yeah, the idea basically is to pack more pixels into the physical inch of the display, and then what gives us is like more of like photographic quality and like smoother edges. So what does it mean for images? For images, it means that if you, let's say, if you show the image on the website that is 400 pixels wide, but your DPI is 2, so it's like you have two CSS pixels per one physical pixel, so they're packed. So then you can notice that if you just serve 400 pixels wide image for that screen, then the image will actually look a little bit blurry and the quality wouldn't be as good, so it wouldn't be as crisp. So what we want to do is to serve 800 pixels image to show it in a 400 CSS pixels on a device with a DPI 2. And if we have DPI 3, then we want to download and show 1200 pixels wide image. So, and the complicated thing is that, as we remember, like from the next generation formats, we have like a different formats of the image that we want to display. Now we also want to display different images for different screens as of like DPI, but also we want to display probably different size of the image, again depending on the device, like a mobile or tablet or whatever. And so that's how it might look like. So the cool part about IMG tag is that we can give it like a different sizes of the say images and say show this size for this breakpoint and that size for that breakpoint. and then it will magically go and figure out what image it want to use. So for example, here, if we have on mobile, it's going to be 400 pixels, and then if the DPI of the screen is 2, then it will just go and pick up the 800 wide image. And if it will be DPI 3, then it will go and pick up the 1200 wide image. And this is actually working quite nicely, and there is not much problem with that. However, there is one opportunity of how you can how we can optimize the bandwidth and the image size that we are delivering. And I'm going to go to talk about it probably next slide. Yes, optimizing for high DPI screens. So yeah, that's an idea that, like, because we are loading, like, let's say for DPI 2, we are loading twice bigger image and showing it into the same, like, into that 400, let's say, pixels viewport. The thing is, if it's a photo, then the human eye can only see as much details. And then the premise that we are going with is that, well, if DPI is bigger, then we can actually use more aggressive compression, pretty much just reducing the quality on the encoder, and then this will save us on the bandwidth. There are two links. So I think that the person who came up with the technique is Jake Archibald. He's I believe one of the Google Chrome developers, and yeah, so he came up with a technique, and then the second link is basically how we are leveraging it, using it in the PixBoost to deliver images for high DPI screens. And then there is another cool website, DPI LV, that can show you all the different DPIs, and you can see that, like, even like iPhone 5 and 6 and 7 is there all like a 2 DPI, and 7 Plus is 246, and then XS3, XR2, XS Mark 3. If you go into like a Galaxies and stuff, there are like a DPIs more than 4, and so forth. The interesting thing is that those high DPI screens, they're most popular on the mobile devices, where the bandwidth can actually be critical because you don't have a good coverage everywhere. And here we go. So this is like what the way how the idea of optimizing the for high DPI screens. So here you can see that we are using the picture tag, which is pretty much using the device pixel ratio CSS selector. Then we can say that we have between 2 and 3, and then more than 3, and you can see here that we are just preparing different images. So this is quality 50. For 3 or more, we're doing quality 40, and then for everything else, we just do the normal quality. And here we have the same things for 100 pixels and 100% viewport width, and we are providing different sizes for this. So then the browser can actually go and pick the right size. Don't forget that to all of this, we now also want to add like a JPEG, WebP, or AVIF, and then the markup just becomes horrendous. So it didn't fit into the screen, but then the idea would be that you have your DPI selector, and then you also have your image type. So then we would also need to have all the AV files in quality 50, and then quality 50 WebP, and then quality 50 in the JPEG, and then we go to quality 40 for the 3 and more, and then for default 1. So if we think about how many images we need to produce at the end, that will be like a lot, so it will be 8 per each here, and what, 20, 24, and then by 3, and it's like 72 images from one. And also you don't really know like what are those sizes will look like, because for different layouts it will be different sizes, so it's kind of becomes then tricky to produce all the different sizes that you need for the all different layouts that you might have on your website. So yeah, that's where the image CDN kind of comes handy. This is the full this full snippet that's supporting next generation formats as well. Unfortunately, we still need to specify the device pixel ratio selectors. And then what we can do here is, you can see there is a new DPPX query parameter that we are passing that gives the API a hint that this is a DPPX2, so we can optimize image further. And here it's DPPX3, and then here we don't pass any, which assumes that it's DPPX1. So now it's more compact, and then also we producing all the different sizes from the original image. So the idea that, again, that what image CDN allows you to do, enables you to do, is to just have one image that could be like very high quality one image, and then you can produce all the different variations of it. So that image CDN can do it for you. So yes, and yeah, that's pretty much it for the high DPI screens and what we can do with images. To it again, that high DPI screen optimizations, if we talk about it, I don't think that you would just apply it blindly everywhere. The main reason behind it is probably because you still need to load the big images, but then if your image on the website is quite small, then even if it's quite small, then in the viewport, then the user probably won't see all the details and stuff. So, and that's also probably depends on what's on the image. So I guess that optimization for high DPI, it's a must have for all the different like hero banners and things, where like it's usually like a very high quality photos that you display there, and they usually take up a lot of space. So that's definitely makes sense. Again, like if you talk about product images, and close-ups should use those techniques as well. Let's say like a smaller thumbnails and things, it's probably up to you, and that's something that you would want to experiment with and see, is it actually affecting how I see the website? Does it add a crisp by using those bigger images or not? And then you can probably make a decision based on that. So there's not really one size fits all, I believe. So probably the last one that we're going to look at is CLS metric, a cumulative layout shift. So in this example, you can see, so on the left is this one is when we just loaded the page is still loading, because that first hero banner is the biggest, is probably the biggest image to load. It might load last, and then so we will see everything but without the hero banner. And then the hero banner loads, and then the rest of the things jumps, and that's what pretty much called cumulative layout shift. So now layout shift just happened, which is very annoying. I know so many sports sites, when you like reading the articles, and then it just starts, you reading already halfway through, and it's just all starting jumping. It's just madness. Never do this. So what do we do to avoid it? We just add a height attribute. So this is kind of happened not a long time ago, actually. So that you could always add width and height on the image, but I believe that it was working a little bit differently. So what it's doing now in this height and width, what you do is you specifying the size of the original image, and then based on that, what happens is like the browser can calculate the aspect ratio. And then if in CSS, if we go back, if in CSS we know that the maximum height of this banner is like, if we know that it should take up the 100 viewport width, then having the knowledge of actually viewport width, browser can calculate what would be the height based on that. And yeah, that's what we pretty much do. So every time we place the image, we just need to add width and height attribute to it, which should be the width and height of the original image, of the one that is going to be loaded. And that's pretty much what you do. And then what we'll see if we edit, then while the image is still loading, it will look like this on the left. So there will be no layout shift, all the caps will be in the same place, and once the image loaded, then we will see it here. Another trick actually that I picked up working on all these hero banners and images and things, is that don't forget that you want your text still be visible, so it makes sense to make a contrast background on the element. So if our text is white, if we don't set a background to black, then we won't see a text. However, if we set background to black, let's say, then we will see the text. And then even though the image is not loaded, but the user will see the text there. And I believe that's pretty much it. That's what's happened in the latest good practices in how you load the images on the website. You can find me on the GitHub, LinkedIn, Twitter, Mastodon, which is new. Yeah, if you have any questions or anything, just hit me up, and I'll also post the link to the slides in comments to this stream. Thanks a lot for watching, and yeah, if you also have any recommendations, so curious about anything in the web performance, just let me know in the comments, and then I'll do the next one about it. Thanks a lot, everyone, and I'll see you later.